Hello, I am Wendy Vasquez, a PhD student in material science at the Autonomous University of the State of Hidalgo. Today I am going to present my research poster entitled Composite Materials, an Alternative Against Bacterial Resistance. To provide some context, antibiotic resistance is classified by the World Health Organization as one of the 10 main threats to public health, causing around 1.27 million deaths in 2024. This problem has had a major impact on science, making it necessary to search for alternatives to combat this phenomenon through research and development carried out by multidisciplinary teams. In this regard, this research project is based on the development of biomaterials with antibacterial activity, integrating some mechanisms of action, like interference in metabolic processes, ROS productions, or alteration in the membrane of the bacteria. The composite material that will be development is based on gadolinium-doped hydroxyapatite reinforced with graphene oxide. This will be carried out by ultrasonic homogenations during two 5-minute cycles at 15 grades and 40 Hz. And first, the respective amounts of graphene oxide and doped hydroxyapatite will be weighed. Secondly, acetone will be added to the graphene oxide and placed in the first ultrasonic bath. Later, hydroxyapatite and acetone will be added and placed in the second ultrasonic bath. The sample will then be left to settle and the supernatant will be removed. Finally, the composite material will be left to dry and oven in at 60 grades. Both materials have been synthesized and characterized. In the XRT analysis that I present to you, the spectrum correspond to hydroxyapatite was identified is this, and as well as secondary groups such as tricalcium phosphate in blue, gadolinium phosphate in orange, and gadolinium oxide in blue that are present on some doped samples, how you can see in these spectrums. After in FTIR analysis, identifies the characteristic bands of phosphate, RCs, and hydroxyl, these groups, in the hydroxyapatite structure. Some micrographs of the hydroxyapatite surface are shown, where agglomerate particles can be seen. In case of the graphene oxide, the main diffraction peak is identified at 10.8 grades theta. Likewise, with FTIR, the functional groups such as carbonyl and hydroxyl are identified, In SEM, we can see the characteristic morphology in the hormone sheets is identified. Finally, in Raman, the D and G bands are identified, confirming the obtaining of graphene oxide. Well, due to characteristic of the materials that make up the composite, a dual mechanism of action is expected, physical and chemical. Physically, graphene oxide will act by breaking or tearing the bacterial membrane, like we can see here. In the best case scenario, releasing vital components of the bacteria, leading to its death. However, some bacteria are capable to regenerate their membrane. In this case, the oxide groups in oxygraphene and the doped hydroxyapatita will have a chemical effect, promoting the production of reactive oxygen species. And if it manages to penetrate the membrane through the fissure, it will cause an ionic imbalance, altering the enzymatic and metabolic functions in the bacteria. And well, with all the results obtained and the corresponding analysis, it is concluded that the optimum concentration for the development of the composite was 1% of gadolinium. Because the presence of the secondary phases formed will favor the antibacterial activity by interacting with the bacterial membrane, causing alteration in its metabolic function. And well, that's all from me. Thank you for your attention and have a great day.